All right, everyone. Today we are going to look at reciprocal trig functions. So we've dealt with sine, cosine, and tangent before. The sine, opposite of hypotenuse, has a reciprocal. Its reciprocal is called the cosecant. So the cosecant would be the hypotenuse over the opposite. Cosine, adjacent over hypotenuse, has a reciprocal called the secant, which would be hypotenuse over adjacent. And tangent, opposite over adjacent, its reciprocal is the cotangent. Again, you would just flip the fraction, so that would be adjacent over opposite. So these three items right here form what we call the reciprocal trig function. So it's just flipping the ratio. That's all that's happening there. So a quick example on that, if we have the following triangle here and we want to find all 6 trig ratios, the first thing we would need to do is find this third side. I'm just going to call that h for hypotenuse. So we could use Pythagorean theorem for that and say 5 squared plus 12 squared equals h squared. And if we solve that, we would get 13. So that side length is 13. Just wanted to refresh Pythagorean there real quickly. And now in reference to theta, we can go ahead and label the triangle accordingly. So this is our opposite, this is our adjacent, this is our hypotenuse. And we can follow standard SOHCAHTOA rules from that point forward. So our sine would be 12 over 13. And if the sine is 12 over 13, the cosecant would be 13 over 12. Nice and easy. Okay, just flip the fraction. That's all that needs to happen. Cosine would be adjacent over hypotenuse, so that will be 5 over 13. And the secant would then be 13 over 5. Tangent, opposite over adjacent, TOA, would be 12 over 5. And the cotangent would be the reciprocal of that, 5 over 12. When we look at these, tangent, cotangent, people usually have no problem understanding that those are reciprocals. But sometimes people get secant and cosecant mixed up. Which ones do they go with? And the way that I look at this is every pair needs to have a co. So if we look at this here, sine and cosecant, there's one co. All right, cosecant within that reciprocal pair. Cosine and secant, cosine has the co. There's one co in that pair. Tangent and cotangent, same deal. So that's the easiest way that I've come up to remember that cosecant needs to go with sine because every pair needs to have a co, and cosine goes with secant because every pair needs a co. All right, these can get a little bit more complicated. We may have a triangle that looks like this. All right, so in this case, what we would need to do is find this side length. I'm just going to call that y. All right, so in order to do that, actually, I lied, we don't even need that. So in order to be able to find sine and cosecant based on this information, theta right here, root 7 is the opposite side, and 6 is the hypotenuse. Okay. So in order for us to do that, sine would be pretty simple. It would just be root 7 over 6. And we could leave it like that. When we do the cosecant here, we'll have 6 over root 7. So this gets into our simplification of radicals. All right, what we would need to do to rewrite this in simplified radical form, which will be preferred, is to multiply numerator and denominator by the square root of 7. So our answer here would be 6 root 7. And then root 7 times root 7 is the square root of 49, which is just 7. And that would be it. We would always want to look to see if the fraction, the items that are outside of the radical, can be simplified. 6 over 7 cannot be. So we are good to go. Just for a quick refresher, I did say we should try to find this first. In this problem, we actually did not need it. But if we did need it, just a quick refresher on Pythagorean, we would do root 7 squared plus y squared equals 6 squared. In that case, remember leg squared plus leg squared equals hypotenuse squared. And then solve for y accordingly.